Okay, so a practical use of my definite integral is actually it evaluates an area under the curve. So you can see in here, this area here, that area is given by the integral from a to b f of x dx. So we can be asked to evaluate an integral and get two possibly different answers, okay? One of them is just evaluate the integral, and whatever answer you get, you get. But the other one could be to evaluate an area. And if we look at something like this one here, you can see that this area here is below the axis, which means the answer I get is actually a negative answer. So if I want to know what the positive value is, I have to put a negative out the front, okay? So if my area is under the curve, to get the actual area, I have to multiply by -1. And even this one here in part C, if I need to calculate the area, I need to work out that area there and that area there. Now, if I just work out the area from A to B of f of x dx, well, this area here will be negative, this area here is positive, and they cancel each other out. So we might get 0 in this case, but that's not true because there's clearly an area. So what we have to do instead is split it up. Okay, work out the integral from B to C, which is positive, and then subtract the area from C to A, which is a negative, and a minus makes it a plus. Okay, so whenever you have to get an area, absolute, non-negotiable, so non-negotiable, draw a graph. You have to have a graph. All right, so as it says, here's the method: sketch and curve labeling all intercepts, work out what they are, and then split your section up. So if we have a look here straight away in example 12, okay, well, first things first. The first part in example 12, it just simply says evaluate that integral, okay? So let's just go with the integral from -1 to 4, and let's multiply through 3x minus x squared dx is equal to the antiderivative of 3x to the 2 on 2 minus x to the 3 on 3, evaluated between 4 and -1. So put those in, so I get 3 times 4 squared, big bracket, over 2 minus 4 cubed over 3, subtract, put -1 in, 3 times -1 squared over 2 minus -1 cubed over 3. So what is 4 squared is 16. So 16 over 2 is 8, 8 3s are 24. 4 cubed is 64 on 3 minus, what have we got? -1 squared is 1, 3 times 1 is 2, and -1 cubed is -1, minus a minus is there. So what's 24 is the same as 72 on 3, minus 64 on 3. I get 8 on 3, subtract 3 on 2, which is the same as 9 on 6 plus 2 on 6, which is 11 on 6. So I get 16 on 6 minus 11 on 6, which is 5 on 6. Oh, it's not even units, sorry. It's just 5 on 6. Because all we've been asked to do is evaluate an integral, yeah? But if I want to know what the area is between the points in the x-axis, you can see we've got 3 distinct areas here. I've got this area here, this area here, this area here. So we'll call it A, B, and C. A and C are both negative values. Now, there's a couple of things we could think about. Since that's my turning point there, all right, I know that this area here and that area there is the same because our turning point also has our line of symmetry, doesn't it? So, which means that area there, which is a distance of 1 from my x-intercept, is the same as this area here, which is also a distance of 1. So what I'm going to do here, I'm going to work out the integral from 3 to 4 of 3x minus x squared dx, and I'm going to multiply it by 2, because that will give me that area and that area. And in fact, I'll leave it as 2 for now. And then I'm going to have the integral between 0 and 3 of 3x minus x squared dx. So from the previous example, I can see what my antiderivative is. So I'm going to go straight to my antiderivative and just go 3x squared on 2 minus x cubed on 3, evaluated between 4 and 3, plus 3x squared on 2 minus x cubed on 3, evaluated between 0 and 3. I'm going to run out of room, so let's put my 4 in. I might just do a shortcut. So 4 squared is 16, 48 on 2 is 24, minus 4 cubed is 64 on 3. Subtract. 3 squared is 9. 9 threes are 27, so 27 on 2 minus 3 cubed is 27 over 3, which is 9. So that's that area. Plus, pop 3 in. So I get 3 squared is 9 times 3 is 27 on 2. Minus 3 cubed is 27 over 3, which is 9. Subtract. If I just put 0 in there, I get 0. All right. So let's evaluate the first bracket. We did that earlier. 72 on 3 minus 64 on 3 is 8 on 3, minus 27 on 2 minus 18 on 2 is 9 on 2. So that's the first area. Plus the second area is 27 on 2 minus 9, which is 27 on 2 minus 18 on 2, which is 9 on 2. So I get, what's that make them both? 6s. 16 on 6 minus 18 on 6. Oops, 27 on 6. Excuse me, 16, 27 on 6. So that gives me 11 on 6. So I got negative 11 on 6 units there. I get 9 on 2 units there. So if we match that off, this 9 on 2 units is the one between 0 and 3. So it's that area in here. This negative 11 on 6 is actually that area there, which is the same as that area there, which is why I have to multiply by 2. Yeah, but I want an area, which means I want the positive value. So what it means is the area is equal to 2 times positive 11 on 6, because I want an area, plus 9 on 2. So 2 times 11 on 6 is 11 on 3. So it's equal to 11 on 3 plus 9 on 2 on 6, 22 plus 27, 49 on 6 units. Okay, so example 13 says sketch the graph of that function and then find the area enclosed by f of x and between 1 and 4. So if we do a quick graph sketch, so we can see that it's x squared minus 4. So x squared minus 4, so there's negative 4 down there. So there's my graph. And hopefully it doesn't take too much to see that's a 2 and negative 2. Find the area bound between 1 and 4. So between 1 and 4, so as it turns out, let's extend that up a bit more. Let's get rid of that bit. So what does that mean? So let's have a look. So between 1, which is there, so I want this area here, up to 4, which is there. So they're the two areas that I need. So clearly this negative area here, that's 1 and that's 4. So since I need an area, I need to split it up. So let's overgo that with red, because now I'm going to say the integral between 1 and 2 of x squared minus 4 dx. Now that gives me that green section, which I know is negative. So if I put a negative sign out the front, that'll turn it into positive, plus the integral from 2 to 4 of x squared minus 4 dx. And that'll give me that positive section there. So I'll work through one side at a time. So let's leave the negative out there. Anti-differentiate x to the 3 on 3 minus 4x between 1 and 2. Negative out the front. Pop 2 in. 8 on 3 minus 8. Subtract 1 on 3 minus 4. I might have to come here, which is equal to the negative out the front. 8 on 3 minus 8 is 8 on 3 minus 24 on 3. So that's negative 16 on 3. Subtract 1/3 minus 4, which is 1/3 minus 12 on 3, which is minus 11 on 3. So we get negative 16 on 3 minus a minus, which is plus. So we get a negative outside of 5 on 3. Yeah, so you can see that the negative 5 on 3 is actually that area between 1 and 2. So we multiply it by a negative to give me a positive 5 on 3 for that section. Do the same thing, I should say, for the red section. Let's anti-differentiate. So I get x to the 3 on 3 minus 4x evaluated between 4 and 2, which is equal to 4 cubed. So 4 cubed on 3 minus 4 times 4. Subtract 2 in the bracket, 2 cubed on 3 minus 4 times 2, which is equal to 64 on 3 minus 16. Subtract, that's a 2, isn't it? 8 on 3 minus 8, which is equal to 64 on 3 minus 48 on 3 is 16 on 3. Subtract 8 on 3 minus 24 on 3, which is negative 16 on 3. So we get 16 minus minus is plus, so we get 32 on 3 for that section. So then my total is equal to 32 on 3 plus 5 on 3, which is equal to 37 on 3 units. Okay, so let's sketch our graph here of this polynomial in cubic. So we've got x-intercepts at 0, positive 2, positive 3. So positive there because 2 minus 2 is 0, 3 minus 3 is 0. It's a negative cubic, so it must look a little bit like, oh, I'll use that one. Up, down, through, like that, yeah? So that's 0, 2, and 3. So clearly, the area that I need is that area there and that area there, all right? So the area in blue is the integral from 0 to 2 of x times 2 minus x times x minus 3 dx. Now that's going to give me a negative answer because it's below the axis, so I'm going to put a negative sign there. And then I'm going to add the integral from 2 to 3 of x times 2 minus x times x minus 3 dx. Now, if I was going to do that by hand, I'm going to expand that cubic Yeah, and you end up with sort of x times, what's that going to give me? 2x minus 6 minus x squared plus 3x, and just expand everything. Minus x squared plus 5x minus 6, and then multiply by x. Okay, so then I anti-differentiate all of that, but I'm going to do it on my CAS instead and show you what our answer should be. One thing to note here, an alternative here, instead of putting that negative sign there, I could in fact just swap those points around and put 2 to 0, x times 2 minus x times x minus 3 dx. Okay, so let's have a look at those on the CAS and you'll see how they're the same thing. Okay, so if we finish off this problem here, you can see from the CAS printout that from 0 to 2, which is this here in yellow, is exactly the same as from negative 2 to 0. So both of them give me 8/3. So I'm going to get 8/3 for the first part of it. And we can see there then that from 3 to 2 of the function gives me 5 on 12. So what's that? 4, 8 to 16, 32 on 12 plus 5 on 12 gives me 37 on 12 units. So the most significant thing there is that just evaluating the integral between 0 and 3, for example, is not going to give me the area. It's going to give me that green section here, 5 on 12, subtract 8 on 3, because the 0 to 2 is below the axis. So to evaluate an integral, just put the limits of integration in and get an answer. That's fine. If you're asked to evaluate an area or find an area, you have to have a graph, okay? So just to confirm there, our last two, our previous two examples, look at example 13, our integral between 1 and 2 of x squared minus 4 dx. There's my negative 5 on 3 that we were talking about, okay? So I have to multiply it by negative 1 to make it a positive 5 on 3. And then obviously the 32 on 3 here corresponds to the integral between 2 and 4, which is positive, which we expect because it's above the axis. Similarly, for the previous example, we can sort of see this negative section here that, remember, we decided was negative 11 on 6. So there's my negative between 4 and 3. So we expected a negative answer. Okay, so we have to multiply it by negative 1 to make it positive. And then through the middle here, between 4 and negative 1, we get 5 on 6. Between 4 and negative 1, we get 5 on 6, which is our positive answer there. Okay, so obviously it's very simple to evaluate the integrals on our calculator, but again, you've got to make sure you split your integrals up into the right sections so that you evaluate the correct areas for each of the respective graphs. Okay.